Okay, I'd like to go ahead and welcome everybody to our third session of our fourth Environmental Health Summit on maternal, child, and environmental health. Today's session is a really special session, and we're so delighted to have Brian Buckley, Nancy Fiedler, and Amy Goldsmith be talking to us about the health effects of pesticide exposures for infants and children, and how we can protect our homes, our schools, and our children. This session explores common pathways of exposures to pesticides and the threat that pesticides pose for human health, with a special focus on their impact on pregnant women and children. Today, we're going to learn practical ways that we can minimize our family's exposures to toxic pesticides, including committing to pesticide-free lawns and using safe and effective ways to rid your home and yard of the most frequent uninvited pests. So with no further ado, I first have to thank Maria Crescencio because she's amazing. I also want to thank Rob Lumbach, who's our Director of Community Engagement at the Center for Environmental Exposures and Disease. This is Community Engagement Corps. So I want to always thank those two, but I also want to thank our SAB members for putting this together and our illustrious CEED membership. So thank you for being here. And right now I'm going to pass it right over to Brian Buckley.
Thank you, Carrie. So I'm going to try and cover, essentially a little bit of background on pesticides in general and some of their toxic properties. And I've got a kind of an interesting story that I think you'll all enjoy at the end. It is a success story, so hopefully you enjoy it. Start off by saying that pesticides we think about pesticides primarily for how we treat bugs, and that's one of the types, but we're also talking about rodenticides, which are the things that, mice and rats and such, herbicides, which are the things that deal with our weeds and our unwanted plants, and the algicides, fungicides, bactericides, all that stuff we've been spraying to try and prevent COVID, they're pesticides as well. And it's something to keep in mind. I'll talk about later on. But one thing to keep in the back of your mind, and I went over this when we were working with transit on disinfection of buses, it's tough to kill the bad guys and leave the good guys unharmed. That's why we've got to be real careful with pesticides. Pesticides have been around a long time. Sulfur and whale oil, arsenic, nicotine, those are things that date prehistory. And then we've gone through, in modern times or recorded history, everything from ethyl bromide, which was still used. It was the primary compound that killed the folks in Haiti. DDT, which you all know about from its notorious reputation for weakening the eggs of bald eagles and how much waterfowl we dissipated. And then some of the other bad guys that I'll cover in terms of organophosphate pesticides, which are related to some of our nerve agents. Okay, the one thing to keep in mind is our use of pesticides has grown dramatically with time, and we find them convenient for helping us grow things. But this is an old slide, but it's still valid in terms of getting you an idea of the order of magnitude. 5.6 billion pounds of pesticides are used every year. There are 800, more than 900, I guess more than 1,000 now active ingredients and 30,000 different formulations, which are mixtures of the actives and transporters and the carriers that bring it to the various locations, as well as the things that keep it around and move it about in your environment. I'll talk about that a little later. Okay, one thing that we've seen in terms of the increased use is it's related to our increased use of nitrogen, which means that the more fertilizer we put down, because nitrogen is a good way to describe how much fertilizer we're using, we're also putting down more pesticides. So we're trying to grow crops more efficiently. We're trying not to let the bugs have at the crops. And the more crops we try and grow, especially in a smaller area, smaller farmland, the more pesticides we use to try and keep things in check. The other thing that's increased is, as more species are targeted, the more products we create. So right now, the hot pesticide groups are the pyrethroids, and I'm not going to talk too much about them because right now they present the least amount of risk of the pesticides that we've created. But one of the reasons for the increase is also, in addition to just the species, is the fact that bugs are becoming resistant, okay? So we'll put a pesticide out there, an insecticide, say for mosquito control, and then we kill the vast majority of the mosquitoes with that insecticide. But the guys that survive, the insecticide, or the insects and the mosquitoes in this case that survive, they crossbreed now and they make a more resistant species. So next time we put down more to kill all those insects, all those mosquitoes. Again, a certain percentage of the already resistant survive and they become the more resistant strain and they find each other and breed. And this process goes on and on and on to the point where we're killing bugs by dropping the pesticide directly on the head, and the weight alone of the pesticide is the only thing that will kill them. The active ingredient no longer has any effect. So that's why we change formulations and try and figure out what's the best way to do it going forward. So I said this a moment ago, pesticides aren't just insecticides, they're herbicides, fungicides, rodenticides, and pediculicides, which are lice. And the reason I'm putting this slide up there is that the Federal Insecticide, Fungicide, and Rodenticide Act, FIFRA, governs their usage and their deployment, okay? And so that's the federal legislation that keeps all of the use contained. So let's talk about how we become exposed to the pesticides. There are multiple pathways. The primary one, or the first one I'm going to talk about anyway, is inhalation, all right? So you're not spraying a pesticide in someone's face. But what happens is you apply a pesticide in an environment where someone else is there or you're there, and it stays airborne for quite some time. Naturally, you're going to breathe in that environment. You frequently detect the smell. They put masks or scents into pesticides to try and mask the smell a bit. If you're smelling it, you're breathing it. So another pathway is ingestion. And kids are particularly susceptible to that because they do a lot of hand-to-mouth behavior. So they're not licking surfaces and they're not eating pesticides directly, although quite possible if you leave a trap on the ground that someone might be able to get a hold of. But what happens is the pesticides lie on surfaces, they travel through dust, they become deposited on a tabletop or on something else. And a kid who's eating their meal may put their hand on that surface, and then they're going to put their hand in their mouth. And so they inadvertently ingest the pesticide. Dermal absorption just happens when you're in an environment where you touch the surface, even if you don't put your hand in your mouth, or if you're applying the pesticide and you get it on you, or you're going to find out later on, you're going to contact things that become pesticide sinks or places where pesticides reside, and they're common places. Things like pillows and cushions and chairs and soft surfaces, they become sinks for pesticides, and they become a place where you might get some dermal absorption or contact and get pesticide on you. The last one is injection, and no one is taking the pesticide, putting it in a needle and injecting it in their arm. But if you cut yourself, or if you're working on a sharp surface and you penetrate the skin with something like a pesticide, that's a route of exposure as well. Okay, so let's talk about how it gets into our environment to begin with. Originally, you're going to apply the pesticide to something, say, crop dusting or any sort of agricultural application. Well, that's not something you put down in your house, but if you live close to a farm, you're going to get something called drift. And the pesticide, while it tended to go to the crops and the vast majority of it goes there, the air will carry some of it and it may carry some of it into your home. And that's true whether you're applying it via a plane or whether you're even just spraying it from a tractor or even when you talk about spraying a targeted application from that can of Raid that you've got, there will be some drift to areas where it was not originally intended. I've got some actually photographic evidence to show you how that happens as well. As an applicator, you can also take it home on your clothing. And if you're a kid, you might be running through an area where it was just applied, and you're going to bring it home on your clothes as well. Okay. So looking at human exposure, pesticides or their metabolites were detected in the general population in 1999-2000 survey. Okay, this is the second national report on human exposure to environmental chemicals from the CDC. We found organophosphates, organochlorines, carbamates, herbicides, pest repellents like DEET, which is supposed to keep ticks off you, and from lots of disinfectants. The popular guys right now are the quaternary ammonium compounds. If we were to look at it today, post-2000, we would also find that pyrethroids are very prevalent because they've replaced just about all those classics as for home use. The problem is a lot of those older guys, the organochlorines, the organophosphates, they have a very long lifetime in our environment. Okay, remember, if you think about places, we use them in schools. We use them on our own lawns and gardens. We use them in cleaning products. We use them to control the ants and the bugs that are crawling through our house on a routine basis. There are also residues in food, so that's why you're encouraged to wash your food, especially your produce when you bring it home. All of these are sources of pesticides for a kid's exposure. Now, here's toxicology of pesticides, or especially insecticides, in sort of one quick, easy slide. This is my very, very rough schematic of something called a neurotransmitter or a neuron, okay? And some of the pesticides, like the pyrethroids and the organophosphates, and organochlorines, attack the axonal membrane, okay? The carrier of the signal, it attacks the membrane. Others, like organophosphates and carbamates, they attack the neurotransmitters and make them hyperactive. So that's all the toxicology you need for pesticides to know what the target organ is, or the target site for the insecticides. And it does it both in the bugs and in the people. Again, harkening back to tough to kill the bad guys and leave the good guys unharmed. Okay. Organochlorines are the ones that I'm going to start with. There, that's the DDT is the flagship for that one. They're stable in the environment. That's why they were a great pesticide. They hung around for a long time. They're neurotoxic, they're cheap, and they're effective. Unfortunately, we're seeing the fruits of our own labor as far as that goes. In a study that we did, just looking at associations, not cause and effect, but just an association, what we found is the concentration of DDE, which is a metabolite of DDT, was higher in our Alzheimer's patient than it was in the age-matched controls. My colleagues are working on the mechanistic reasons, what's happening at the cellular level, to try and figure that out. But for right now, just know that there's an association between DDE, a long-lived organochlorine pesticide, and Alzheimer's. Organophosphates, which encompass the same class as the nerve agents that we use in war or have been used in war. They're a class of esters, and they are toxic for both pests and vertebrates. They are less stable, although more recent data has seen chloropyrifos, which is one of our actors that we're going to talk about a lot today, stable for up to 20 years in some environmental samples. They're still seeing chloropyrifos around today. And that was not originally expected. And that's going to bring me to my story, because it's the duration of the pesticide, how long it's stable in your environment. Ideally, we want a pesticide to be applied, kill the bugs, whatever they are, and then go away very quickly. Organophosphates hung around for a lot longer than anyone ever expected. We did a study a bunch of years ago looking at volatiles, and pesticides, okay? Our original hypothesis was that some of the complaints that Department of Environmental Protection in New Jersey were getting were actually related to the vehicle or the carrier. So in other words, in order to distribute the pesticide, it has to be dissolved in something that's volatile and is going to carry it to multiple surfaces and create a greater area of coverage, a greater application area. So we looked at the duration of the volatiles after an application, and we used actually some dorm rooms over on Rutgers Bush campus. We had availability in the summer because no students were in there. They made nice reproducible testing places. We did a normal pesticide application, and what we found was that they were around for a lot longer than anyone had anticipated them. But in addition, we found out that the pesticide itself hung around for a lot longer than anyone anticipated. And we were looking for ways that we could measure this, and we chose a bunch of different things. As I said, other people had done things like pie plates and aluminum foil and whatever else. We wanted to be different. I was working on a study looking at the amount of chromium and lead in children's toys. And we had actually had a child with a high blood lead, and it turned out she was sucking on Big Bird's nose. So I had scores and scores and scores of these Big Birds in my office that we purchased from every manufacturer we could think of. And when that study was done, I had all of these leftover Big Birds. So when we went and we did our pesticide study in the dorm rooms, we brought Big Bird with us. And lo and behold, when we looked at Big Bird, 300 hours after application, we found that we could measure concentrations of the chlorpyrifos in Big Bird. And when you sample the same Big Bird with respect to time, Big Bird doesn't do well. Fortunately, the IRB approved our use of Big Birds for the use of the betterment of society, so to speak. Just this study alone was enough to get us to do more studies, meaning the federal agencies who look at these things funded us to do more work in this area. And we looked at chlorpyrifos as our target pesticide and its residue on surfaces and on toys accessible to children. And we started doing all kinds of studies. So why are we looking at children? Well, it's estimated that, children are full-time in the home. So if you're going to apply a pesticide in the home, the kids, especially the young kids, and unfortunately the ones that are most vulnerable, are going to be the ones that are going to be most exposed because they don't get out of the house nearly as much as their older siblings or their parents who work outside the home. Generally, the kids are there most of the time. And as you can see from this illustration or this picture of my daughter when she was very young, they also put their hands in their mouth a lot. So there are multiple routes of exposure. They're on the ground. They're going to contact the surfaces where pesticide were applied, but they're also going to get inadvertent indigestion. The other thing that we want to keep in mind is that kids are especially vulnerable because they're undergoing development of the neurological processes, especially when they're very young. And because the insecticides primarily target the neurological pathways, remember I showed that neuron before and where it targets. And I want to be clear, I'm talking primarily about insecticides now. Other pesticides, such as the quaternary ammoniums, use different mechanisms, but all have the potential to create perturbations at best, meaning an interruption of normal processes in people. But especially kids are vulnerable because they're young, they have a lot of surface area to the volume that they are, and they're undergoing neurological development. So they have all the bad stuff going for them. Plus, they're in the environment where pesticides are. So Paramita was the graduate student who did most of this work. And here you see her with a picture of putting a bunch of different survey media on the walls. And we put some at kids' height and we put some at adult height because it was a crack and crevice application, which meant they put it all along the space between the floor and the wall. But pesticides migrate. and they climb up here, and they eventually even make it up to where mom and dad would put their hands. But we were primarily concerned about the kids. And these are just different surface types to mimic, wood paneling or some sort of wallpaper or just a smooth surface that you might get we can approximate with aluminum foil. Okay, and we did something we call grid sampling. And what we would do is put down grids, and we would wipe a particular grid on a particular day to try and figure out how the pesticide might continue to migrate into the space. One of the things that we found is that even when we wiped the space, the pesticide would migrate back. Okay, if you look at this is we introduced a fluorophore, a compound that fluoresces under black light, and we put it there to show where pesticides migrate. And we found that even in some areas, you can see where we cleaned here, the pesticides migrated back there, and they're designed to do that to be more effective. Okay, so we did a lot of this grid sampling, and we reported our results on multiple things. Child's bedroom areas, they were out 29 days application. We had measurable concentrations. We were measuring it in the toys, on the floor. And we used some unique sampling. We did air sampling because that's how you might expose the baby bottle. We did that wipe sampling I described before with this wipe sampler, but this was my favorite, to do the toys, especially the soft plush toys. We wanted to make sure the kids couldn't get at the toys while we were doing sampling, so we put Big Bird in a cage, and that kind of worked reasonably well. We measured air concentrations 9 to 11 days out after application. Again, they're designed to re-volatilize, get back into your environment, but this is the scary part. We measured concentrations in toys more than 11 days. The original applicators of chlorpyrifos said it shouldn't be around that long. So when we started finding it also in kids by sampling urine and did surveys to find out how much time the kids spent on the floor and rinsed their hands and measured the pesticides days after the application, EPA took notice. And what happened was on January 25th, 2001, chlorpyrifos was agreed to voluntarily, more like voluntold, to be removed from potential exposure in children by removing it from all home environment applications. So that's my presentation. Good story. We got chlorpyrifos banned. I can tell you what the follow-up is if anybody's interested, but for right now, I'll take any questions, or we're going to wait till later on.
We're gonna wait until later on, Brian.
Okay.
Okay.
I'm going to stop sharing then, and I'll turn it over to Dr. Nancy Fiedler.
Okay, thanks, Brian. That was great. Okay. So, do I hit share?
Yes, you need to share your screen.
Should be in the toolbar,
Yep, got
drag
it,
your mouse.
got it. Yep, I got it.
Got it, good.
Can you
Here
see
we
my
go.
screen?
We
Are we
see your,
good?
we see your
Okay.
screen, yes.
Okay. Okay, so I need to
While
go-
you're organizing that, I will say that you got a shout out. You got a nice presentation, Brian. We got some feedback that you did a nice presentation, and we also have a comment from Mike Gotchfeld, and Mike Gotchfeld is saying, wait a minute if I can find it. Good exposure good exposure summary. So keep it up, guys. Thank you.
Okay, are we ready?
We are.
Ready.
Okay, so that was a great overview of how children, and particularly young children, are exposed to pesticides. And what I'm going to focus on is how do we know what the health effects are? We know that there are pesticides that are widely used, as Brian talked about, and that children are uniquely vulnerable to being exposed. But one of the things we also need to understand is what kind of health effects are occurring with pesticide exposure. So I'm going to talk a little bit about the different kinds of pesticides, but focusing most on the organophosphates and also the pyrethroids to some extent. As Brian talked about, which I won't spend a lot of time on, is that the various categories of pesticides that are used. But just to highlight the ones that are have been looked at and we're beginning to understand more about health effects in children, the herbicides, things like paraquat, glyphosate are a couple of examples. And then if you go down to the insecticides, organophosphates, as we talked about, organochlorines, pyrethroids. And one of the issues is that, you know, we know more about those pesticides that have been used over many years than we do some of the newer ones, like the pyrethroids and also glyphosate, for example. And one of the issues that comes up a lot is that we kind of presume they're safe until proven otherwise. And then we begin to do studies to find out, well, okay, what are the actual health effects, which I'm going to talk about. This is just another example of how many different products that include pesticides are available to the public in hardware stores. And also these ads, actually courtesy of Mike Gottfeld, drawn in the 1940s by Dr. Seuss actually, are for pesticides that were used at that time. So clearly they've been around a very long time and we've had many opportunities for exposure. So what I'm going to talk mostly about are the extensive number of studies so far that have been done looking at exposure to the fetus, so maternal exposure during pregnancy. The reason we're mostly interested in that is that because that's a particularly even more vulnerable time for development for the fetus, and then that may have impact throughout life if you are exposed and depending upon how much exposure occurs during development. We know that pesticides pass through the placenta and also the blood-brain barrier. So it isn't as if, even though it looks like the fetus is very well protected, in fact, for these kinds of products, they are not well protected. As I said, organophosphates, they inhibit acetylcholinesterase and they allow acetylcholine to build up at neuronal junctures. Now, what does that mean? Well, acetylcholine is a neurotransmitter, as Brian talked about. And if that builds up, then that has effects on neurons and motor function when an adult or even a child is overexposed. But when you're talking about development during pregnancy, this can have other impacts, even though the mother may not have any of the symptoms of a pesticide exposure, like tearing or as watery eyes, for example, and they may have none of those kinds of effects that they experience clinically, and yet those pesticides may be passing through to the fetus, and they may be affecting the neurotransmitter system that's developing in the fetus, depending upon at what trimester the child is exposed. And so this can disrupt cell replication, differentiation, formation of the synapses, all of the kinds of things that need to happen for normal development during pregnancy. So that's why we're quite concerned about exposure to pregnant women. Also, the fetuses and young children are particularly susceptible because during this time there's rapid brain development, as you understand, not only during pregnancy, but also then after pregnancy and during early infancy and early childhood. And the children also have lower than adult levels for the enzymes that detoxify or deactivate the organophosphates. So there are a lot of pathways for the adverse effects of pesticides and for the unique susceptibility of children. So how do we know what happens? So I'm going to talk a little bit about several birth cohort studies that have been completed or are ongoing following children and looking at their exposure before they were born and then following them over time. So first of all, you need to understand that any of these insecticides, they're not expected to selectively affect one particular brain region. They affect, as we've been talking about, this neurotransmitter system, the system that signals nerve cells. And we know that the nervous system is integrated in a vertical way. So in other words, first the development of the brainstem, the very basic functions, and then the development of the limbic system, which is control of emotion and also behavior. And finally, the cortical system, which we all think about in terms of, you know, children's ability to learn, to remember, to pay attention. And we can assess all of these different functions in very young children. And so I'm just going to give you some examples of some of the studies that are ongoing now that I'm involved in, but that have been done by others as well. So from 0 to 18 months, we can look at infant attention and processing speed. And those functions lay the groundwork for later cognitive development. So if you have disruption very early on because of perhaps neurotransmitter effects based on exposures to any kind of neurotoxicant such as pesticides, then you may get disruption in infant attention. And you see here at the top of this slide, there are two infant faces. And what we find, first of all, infants are most attracted to human faces, but we also know that once they are sort of satiated with a familiar face, then they'll look to an unfamiliar face and they'll be attracted to the unfamiliar. And that's how humans learn. Once we know, okay, we already know what this is about, well, we want to look at something new. So we can measure in milliseconds how much time an infant spends looking at a familiar versus an unfamiliar face. And that gives us a clue as to how well they're developing their ability to process new information and to develop attention, which is required before they can ever learn and remember. So then you move to the 12 and 24-month phase. And this is where the infants and young children begin to be able to regulate their emotion. And that's really important because any new mom knows that once your child can begin to soothe themselves and stop crying or have to be soothed to stop crying, they can then be able to learn more information from their environment. So that's a very important function that develops in that age range and continues to develop as children get older. And what you see here at the bottom is one slide with this fake spider who's traveling around the room by remote control, and the child with the mom who's a little bit afraid. And we can actually measure the child's response to these kinds of episodes, and then understand how well can they soothe themselves and develop that regulation. And you can also see the little boy staring at the marshmallow. He's been told he should not eat it until he's given permission. He's really struggling with this. And then as we go into early childhood and adolescence, we're talking about things that most of us are familiar from school, of learning and memory, and the ability to problem solve. So the studies that have been done thus far and that are continuing are studies looking at the organophosphates, one in California among Latino agricultural cohort. These are farm worker families, so the kids live close to the fields and are exposed by playing in the soil and in areas around the fields. And then another two different studies done in New York City. These studies were based on residential pesticide use. So these are studies of families living in apartments or rent-controlled apartments where there is regular spraying of pesticides to control pests that clearly do need to be controlled. And these are families who have probably more routine exposure perhaps than others in other situations. And in these birth cohort studies, and these are studies where moms are recruited during pregnancy, and then their exposure is measured through urine samples most of the time, or through cord blood samples when the children are born. And they look at these and then try to assess the infants as very early on, right after they're born, as you can see at this top picture, and then also as they grow and develop. And what we found in these birth cohort studies is that when we look at mom's exposure during pregnancy, that is then associated with abnormal reflexes in these newborn infants. We also know that mom's exposure during pregnancy has been associated with scores on a test, a clinical test of mental development at 24 months of age in the children. So things like what this child is doing is matching colors and those kinds of tests. But what's interesting is that in this study, at least in California, when they looked at the child's exposure by looking at their urine samples, they did not see an association, an adverse association with mental development. So we're homing in on the fact that it may be that the exposure during pregnancy, which makes sense because it's even more vulnerable time for development, is probably more important in terms of outcomes than even the child's exposure, depending on where the child lives. We also know that these children were followed over time, and that we saw that just measuring the exposure to cord plasma and that later predicted development at 36 months. So as the child grows, it becomes more evident the effects from maternal exposure on their development. We see that at about 5 years of age, we start to see problems with attention. We can't really diagnose attention deficit hyperactivity until the kids get closer to school age. And then we start to see the effects of prenatal exposure on the development of, for example, attention deficit disorder, and also maternal reports of pervasive developmental disorder. This is an example of very serious exposure happening many years ago that started as early as the 1940s. These are children in Mexico who were, some of whom were exposed to a combination of organophosphates, pyrethroids, and organochlorines used on farms. And you don't even need a scoring system to understand that on the one side where you have these draw figures, they actually look like figures, and on the side where they're very crude at 54 months, you see the heavily exposed kids can't even draw these figures. And this is, again, an example of a mixture of exposures that happens on farms or has happened on farms, and that persist, and that you can see effects in the children, particularly for those kids who are heavily exposed. I want to highlight here, many of the studies in the past have focused on one exposure because we can, develop the most sensitive studies. But that's not what happens in real life. Typically kids and adults and all of us are exposed to multiple exposures, and I think this is a good example of what can happen. And so I have one slide also about the pyrethroids. Pyrethroids have been used more, or are being used more heavily, and we've kind of assumed that they're less toxic. So there haven't been as many studies done. Some of the studies that have been done in France and in New York City have not shown adverse effects on infant neurodevelopment, but studies from China and Mexico have shown some deficits in infant cognition. Another study in South Africa has shown that for every 10-fold increase in maternal pyrethroid metabolites has been associated with a decrease in language and expressive communication, again on this Bailey scale, which is a clinical scale. So this is just a summary of some of those studies, but we don't know nearly as much about the pyrethroids and their neurodevelopmental effects. We're going to be looking at that more in our own studies here and going forward. And this is one of the issues that we have, is that, the pesticides get used for good reason in many situations, but we don't really know what their health effects are until we begin to do these kinds of longitudinal studies. So to follow up, the birth cohort studies I talked about in New York and in California, they've continued to follow these kids up through 7 and 9 years of age. And this slide just summarizes the fact that whether we're talking about residential exposure in New York City, or we're talking about the Chamacos cohort and agricultural exposure, what we again see is that exposure during pregnancy, so this is many years ago now, is associated with losses in IQ, an average of loss of 7 IQ points when we look at those who were most highly exposed during pregnancy versus those who were most at the lowest quintile of exposure, or the lowest 20%. We see that for every increase across the distribution of exposure, we see a decline in IQ, and we also see a decline in things like working memory, how fast they process information. So again, it's pretty remarkable that we can see these kinds of effects over this kind of time period. We also, as I mentioned, see an increase in ADHD or attention deficit hyperactivity disorder. And we see this as the children get older and it becomes more evident, and their accomplishments kind of diverge from what we would expect them to be able to do. This is just an example of a test that we use where you can measure reaction time and how quickly or how distracted the child is. And that we see again from prenatal exposure, we see an increase in ADHD. And we also see some divergence in terms of sex, so that boys appear to be more affected than girls, which is often seen when we look at neurotoxicants, whether it be pesticides or other kinds of neurotoxicants. To complicate things a bit more, but to help us understand, we also have had some evidence that there are genetic modifiers of effect. So, for example, the PON1, which is an enzyme involved in the metabolism of OP pesticides, we know that those moms who have a particular PON1 genotype are more likely, their kids who are 6 to 9 years old are more likely to be affected though than the moms who didn't have that particular genotype. So again, showing greater susceptibility depending upon your ability to metabolize and the genetic information that you have to help you metabolize these kinds of compounds. And as we go forward, we're going to learn more and more about the differences in metabolic effects. So this is a perfect time, I think, to turn this over to Amy Goldsmith, who's going to talk about what can we do. We're not wanting to scare anyone. We all have to use pesticides sometimes. We certainly don't want to use them and drown the pests, but we do need to use them at times for our own health. We know that EPA has now moved ahead to finally ban chlorpyrifos, even on foods to protect children's health. But we also know that other chemicals will likely take its place. We talked about
Hey, Phil, how are you?
for example. And so we're going to move ahead and
I was, when you called the first time, I was actually making the presentation.
Brian, your microphone, there you go. So we're going to move ahead to look at those compounds as well and their health effects. So now I'm going to turn it over to Amy Goldsmith. She's the New Jersey State Director for Clean Water Action and the Clean Water Fund. And she's going to talk about some very practical solutions for how we can avoid the adverse effects of pesticides. Amy, I'm going to stop sharing now.
Thanks, Nancy and Brian. Really great presentations. And as Nancy said, I'm going to sort of talk about the sort of right to know and practical applications of non-toxic, non-pesticide laden options. And thank you, Maria, for bringing up the slides. So I'm going to talk about some options in your home and schools, and obviously it's going to help our children have less exposure. Next slide. First, I want to talk about the fact that you have a right to know. New Jersey has laws on the books that give you the right to know on a number of things. One is whether you live in a multi-unit dwelling or you're in a public building or a daycare center, you do have a right to know. And you know those little flags you see on people's lawns or maybe your lawn? That's a result of my organization, Clean Water Action, lobbying for a right to know, so that you can decide not to walk on a lawn or have your pets or kids walk on those lawns because there's been an application made. You can also ask for information, and if you're concerned about an improper application of pesticides, you can call the New Jersey Pest Control Program. And if you feel like you or a loved one has been exposed, or you feel like you're in a poison emergency, there's poison control, which is 24/7. Next slide. The other is that, you know, some people try and apply pesticides themselves, and other people hire people to do that, most often for lawns or termites, or some big, you know, infestation of fleas, or things like that. Make sure you use a licensed applicator. Don't go with some fly-by-night, somebody who's experienced, they're trained, they have insurance. make sure they come and inspect your home. Don't have them just come in, and say, okay, I'm going to do this, and never really look at your home. Avoid chemicals at all costs and all efforts. Make sure you have a written contract about what you want. Spot treat wherever you can, and make sure that they explain why they're doing what they're doing, what they're using, so that you can make an informed decision. And if they're not willing to do any of those things, then don't hire the pest control company. Next slide. The other thing that my organization, Clean Water Action, did in 2004 is we passed a integrated pest management law for schools. This applies to public, private, and charter schools. They have to, there's training that's required for the pesticide applicators or the pest managers in the school, including the principal has to get training. They have to send you an annual, if you're a parent, to send an annual report if they've used chemicals in their schools, and to give information about what they've done. But if they are going to use chemicals, they have to notify students, parents, staff, including staff, 72 hours in advance, and there has to be at least a 7-hour delay before reentry. They have to give the reason why they're using the chemicals, what the adverse impacts are, and if somebody does not get the information, either that annual report or an application of chemicals was used, but they were not informed, again, they can call the Department of Environmental Protection Pest Control Program. Next slide. Now, a lot of people like their lawns, but lawns are not the only thing in your home. They're also on playing fields, and our children are exposed to these chemicals along with our pets. Pets are sort of the first things that living beings that get, in addition to the pests, obviously, that get sick. There's been a very high rise of cancer of pets, and it's often associated with the use of pesticides on lawns. Dogs, cats roll on lawns, and they bring in the pesticides, but they're also ingesting and being exposed. I gave a cat collar, to my, that had pesticides in it, and my cat foamed at the mouth. So, cats do get sick along with people. A healthy lawn means that you'll actually, have them more tolerant of pests. You can also have a lawn that's not a lawn, like I do in my front yard, which is all wildflowers and perennials, and growing more drought-resistant varieties of those perennials, but also growing a variety of grasses so that, when it's really hot, you'll have some grass there that'll tolerate the heat while the others die off. And a taller lawn, 3 to 6 inches, is a healthier lawn. It also crowds out weeds. And making sure your lawn is properly, has the proper pH and fertilizer on it. One of the biggest problems is a lot of these fertilizers have combination fertilizer and herbicides in them. It's really hard to get one, just the fertilizer part of it, without the other. But Clean Water Action did pass a law about 10 years ago that requires the use of slow release fertilizers, and that also reduce different kinds of pests, and including, although we don't talk about it this much in my presentation, but algicides. A lot of herbicides are used because these fertilizers end up destroying our lakes because they fill them up with algae, and then they start using herbicides. So it's this, keeps the cycle going. So, watering properly, and also, attracting good bugs that will eat the bugs that you don't want so much, right? So all of those things are good things to do. And the one thing I want to say also is that, as I mentioned earlier, lawns are not always just in homes, they're in playing fields. And we have been trying to get a Safe Playing Fields Act passed in New Jersey for several years now. It's been really quite a challenge. I don't know why it's such a challenge. We actually had a majority of the legislature co-sponsoring the bill, and yet it never got posted. But we do know that kids, there's lots of soccer being played, there's lots of lacrosse and all kinds of games being played on fields, and they're applying chemicals. These are very active kids starting at the age of 3, 4, all the way through high school. And I've had staff, who I give a presentation to them about lawn care, and they're like, oh my gosh, this kid was 16 years old and she was a cancer survivor because she played on soccer fields year after year, month after month. So it's not just your backyard. It's also those playing fields and in the parks. Some towns have passed pesticide-free playing ground policies, but there are maybe a couple of dozen in the state of New Jersey. Next slide. So now I'm going to talk about some things that we don't really like talking about. And all of these slides will be made available to you so that you can use them kind of as your own, handbook when you try and refer back and figure out what to do. So with rats and mice, and with many of these pests, the big thing is they like warmth, they like water, they like food. So if you keep those things out of their reach, they're less likely to be present. With rats and mice, they're looking for trash, they're looking for wood piles. They actually look for, food, but also pet manure. They like to hide. So seal your containers, fix your screens and holes. Mice and rats get in very tiny holes, also along pipes. And you can use a variety of things. In addition to, sanitation, you can use a variety of things, live traps, you can use sticky traps, you can use snap traps that kill them. You use different bait, and make sure when you handle any of these traps, you're wearing gloves so that the human scent is not on them. Next slide. Now, ants and roaches, we see ants a lot seasonally. Ants don't really transmit diseases. They're just kind of annoying. Some of them like sweets, some of them like grease. They like crumbs, they like pet food. I've seen pet food literally walk across my kitchen floor by a bunch of ants. So cleaning, sweeping, one thing I do is, if I see a whole pile of ants, around my cat food, besides the fact that I throw the cat food out, I just literally get a dust broom and I sweep them and I throw them out of the house. So roaches like water and good hiding places. So again, remove the food, caulk up, cracks and crevices, use vinegar and cayenne pepper along the path where the ants and roaches follow a line. They usually have a direct path. There are roach motels, they check in, they don't check out. These are because there's smells or pheromones that attract them into them. Those are pretty safe for kids. Kids aren't gonna, eat the roach motels generally, and it keeps keeps kids and animals out of harm's way. So again, fix leaking faucets. That's another really big thing. Keep water out of the sink. Manage your leaf and rubbish piles more effectively. Next slide. Now, fleas, they basically ride in the back of your pets. They survive a long time on one blood meal, 7 to 8 months. Things to do for fleas is to, one, either don't let your animals out of the house. That's one way to do it. Pretty hard to do with a dog, but cats, try and keep them from going outside. The other is vacuum, all your crevices and cracks, empty your vacuum bags when you're done, wash your floors, flea comb your pets from the head down to the tail. Some of them will tolerate baths. I know my cats will not. And some people use, flea control products. I have gotten away from them in part because, I've seen the effect on my pets, but keeping them under control. The other thing is if you go away, don't close up all your windows in the summertime. You will end up with a flea catastrophe in your house. That happened to my parents one year when they left and the dog was not there. It was probably half an inch of fleas everywhere. So next slide. Now, head lice is a big problem for kids. Head lice is something that is because kids are sharing things, brushes, scarves, pillows, mats, you know, at daycare centers, or blankets, other personal items. One thing that's really important is don't share things. Now the nits and fleas, they bite, they like blood, and there are a few non-toxic, you know, products that you can get. The only one I have ever found is actually at Walgreens, and I don't remember the name, but you could find it. Many of them do have pesticides in them. The best way to do it is to manually remove the lice. Next slide. As I'm scratching my head, right? So you can suffocate lice with using a coconut oil or an olive oil. It also makes it easier to get the brush through. Use a nit comb, you'll see here in the picture, and go section by section. When you get the lice, you know, off the, you know, on the comb, then dunk it in soapy water and just keep going through it. You have to do this. Then wash, you know, wash the hair, blow dry the hair, take all the stuff from your, you know, your pillows and whatever, and put them in the laundry. Put a pillow, a towel down on top of a pillow that you think will get reinfected, so you don't have to wash everything all over again. Vacuum as much as you can, furniture as well as the bedding and the floors and the carpets, and you have to do this over and over and over again. But it is a way to do it without chemicals, and it does work, because my daughter has come back from camp several times with head lice. Next slide. Something that's very common in our backyards, and many people are allergic to wasps and bees and hornets. These are non-toxic ways. They basically have either a smell or, you know, like a pheromone, or there's a sweet substance and they go in. The one all the way on the left is a make your own. You can make it out of an old soda bottle. They go in, they can't get out. The same as for the store-bought option. The one that looks like a tennis racket, if you're, you know, the aggressive kind, do you like to go whacking bugs and killing them? This is, they're zappers. They have a slight charge to them, or you could use a fly swatter. But these are, you know, unless they're carpenter bees, bees, wasps, and hornets are aggressive, and you don't want to get stung. So these are ways in which they passively go into something other than the zapper and get caught and will not come out again. They're very effective. We've used them at festivals where, you know, wasps were everywhere, yellow jackets were everywhere, and they were able to run the festival and in a food area and not have to worry about, you know, somebody getting stung. So they can be very effective. Next slide. So the one thing that's really important for everybody to know is that we don't live in a pesticide-free world, and we need to be informed. We need to ask questions. We need to compare our options. I use YouTube a lot to find things. You know, you can find how to make one, you know, the bee, you know, do it yourself bee trap. Use the least toxic options first and always. And in many cases, what you're using, whether you're using cayenne pepper or vinegar or something else, you know you're not going to harm your kids. You're not going to harm yourself. It's something that's cheap. It's on your shelf because you're using it for something else anyway. Caulking has the added benefit of, you know, weatherization and reducing, you know, other kinds of leaks and other problems. So in some cases, you might have to do a toxic option, but even with termites, which I didn't discuss at all, what termites are looking for is wet wood. So if you find the wet wood and you remove it, you will not have termites. So they're looking for food, they're looking for warmth, they're looking for water. You can cut that off from their, you know, from their access. You're less likely to have these. And again, you know, your lawn, your garden, your home can tolerate a few ants, you know, a few bugs. So don't go broadcast spraying. Don't use, you know, go crazy for something that maybe all you need is a fly swatter. Next slide. This is my contact information. There's also a great video that ISLES, another organization that we work with called Arrest the Pest in Your Nest, that Brian had brought to my attention. I had forgotten all about it, but it's a great video to use. It goes right into your homes and talks about some of the options to use. So if you want to watch that, that's a great option too. And thanks, Brian, for saying that, you know, wasps and bees are great pollinators. They do other great things. So killing everything off is not always the best option. For me, actually, I have carpenter bees that come to my house every year. And I literally, they're so slow, so big, and they don't have a stinger. I literally collect them in jars. And I do about 100 of them every year. And I take them to a park that's, you know, quite a distance away from me, but I put it in a, you know, they have lots of wood they can chew on, but it's like, at least it's not my home. So on that, I will stop and we'll take questions.
And Mike Gottschall gets credit for the information about the wasp. That was not me. So.
All right. Sorry. Thank Mike.
Okay, so Mike actually did come back also with another comment saying that some wasps are valuable pollinators, particularly if years where bees and butterflies are scarce. So thank you again for that. I want to ask everybody permission if we can put, people are asking for your slides. Nancy and Brian, can we have your slides?
Sure.
All right. We'll post them on our website. Maria will do that. She's fabulous at that. And then if you guys want to ask, we don't have too many questions. We have some more kudos for both Nancy and Amy, as well as, you know, we heard kudos for Brian before. But if you guys would like to ask each other a question or refer to something, or now's the time. If you want to. If you want to, I'm going to open it up for you guys to ask each other a question or make a statement about your presentation.
Well, just Nancy was bringing up pyrethroids, and I said that they are the latest and greatest. They are better from a health standpoint than either the organophosphates or the organochlorines. They photodegrade, meaning sunlight degrades them. They thermally degrade, which means that heat degrades them. And our bodies are better at metabolizing them. Having said that, and I want to make sure I'm very clear about this, anything that does a neurotoxic targeted endpoint, regardless of how well you metabolize them, potentially create risk, especially in a developing child. So just keep that in mind, that we've gone to better classes now, but there's still potential risk from exposure and net health outcomes.
Yeah, and I think that's a great point. I think that, you know, things have gotten better, but we always have to be vigilant about what the new products are. And I would say that if you're pregnant, particularly, that's a time to really, really be cautious, because I think the data with regard to exposure during pregnancy is probably the most compelling, if you will, in terms of risk.
Right, and there's never, I hate, maybe saying this in an absolute way isn't the right way to say it, but I've never seen a chemical that's been deemed safer than when we start. We always find out as we go along that it's more dangerous, and has more impacts. So it's better to always be safe, especially, you know, in a confined space like a home, or a daycare center, or where people are most vulnerable. We do know that you can do an organic lawn. There are lawn care services that do organic lawns. Even True Green, if you ask them, do have an organic lawn section, but they, it's just cheaper and easier for them to just come and spray. It also means that workers are being exposed, and those workers are tracking that stuff back into their homes, either knowingly or unknowingly. And I've seen people literally spraying their sidewalks and spraying their boots and their clothes. I mean, it's just, it's, to me, it's horrific that people are doing that. They could just use hot water and get rid of those weeds, or they could pull them up. I think our tolerance for, sort of this perfection is really, for the aesthetics is a little over the top. I mean, I understand that there's some safety issues, but DDT was not the answer to mosquitoes necessarily. I know because when I was in college, many, many years ago, I was working with a professor on literally the swarming of midges, which are like mosquitoes, to figure out what's their biological patterns so that we can figure out biological ways to control mosquitoes. So there are other options.
We do have a question, Amy, for you and for Nancy and Brian. Do you have information on what insecticides are commonly used on residential lawns in New Jersey? And that's from Elizabeth Marshall.
Often there's one you can look on the bag of the lawn care, but a lot of it is glyphosates, which are now really into question. Roundup is the common substance, which is been called into question around health issues, persistence. It's very commonly used. People spray it, apply it, pellets, all kinds of things. So there's a group called Beyond Pesticides that also has a lot of information about this, but Roundup-like products are sort of the common term that you'll see on the shelf if you go into a Home Depot.
Mm-hmm.
And glyphosate and the herbicides that Amy was just talking about are designed to kill actually anything green that you spray it on. From an insecticide standpoint, though, it's generally pyrethroid based, and it's usually a mixture of 2 or 3 pyrethroids in any formulation that they're using today. There are some others, fipronil and a few others, but generally today, almost every application for residential is pyrethroid based.
Brian, what do they use on golf courses, for example?
Yeah, that's a good question. I don't know off the top of my head. I do believe there's still some organophosphates that are being used in commercial applications, especially, we unfortunately generally tend to think about golf courses as one of those really safe places that we can apply, right? Because you got no kids crawling around on it.
Mm-hmm.
It's not a confined area. It's not going to be a product that's consumed like a food product would be. Unfortunately, what most people don't realize, and Amy made me think about this a few minutes ago, when you apply anything to a surface like concrete, it's not necessarily the damage it will do to the concrete, because it won't. But when you have a rain event, you're going to wash it into the storm sewers, and it's going to become part of the stream. So anything that you do to an impervious surface has to be done with care, and that's also true with golf courses, because they put down first of all a lot of fungicides to make sure that the grass doesn't go brown and get diseases. But because they put down so much, and because they water so often, a lot of what they apply winds up downstream from the actual golf course.
Right. There's a lot of mercury in the fungicides, and they've never been able to really reduce that. And because we're in such a moist state, a lot of fungicides, especially in New Jersey, are used. There are some golf courses that have done more IPM and have done more organic, but they're very far and there's like less than a handful of them that exist. The Pine Barren Golf Course down in Jackson area has done actually a lot of work to like maintain native species and has sort of reduced their footprint. So there's some things that golf courses can do, but tracking that stuff back into your home or into a building, or the pattern of licking balls, golf balls. I'm not a golfer, but people lick their golf balls. Like, don't do that. Stop.
Doesn't sound hygienic, right? Doesn't sound hygienic.
No, it's not very hygienic, and I don't know why people do it, but there's a reason, and then, you know, it's on your gloves and everything else, so.
Well, also, it's not uncommon for people to have really nice homes built along golf courses, right? Because it's a beautiful view.
Right.
So that's even more opportunity for exposure, actually. For the
Right,
people.
not just for the air, but, you know, if you're in a more rural area, you know, you might be on wells. So imagine you got pesticides being used and then it ends up being in your well water.
Right.
And you don't know that. Right.
So
You think that this
Stephanie
might be a great
Hamill
place.
on the chat is giving, alerting us that Audubon gives certification to golf courses for being friendly to animals.
Right, and this Pine Barren Golf Course actually was designated as they have like a wildlife status, but they also do other things at this particular, they do a lot of water conservation work and other things at that facility if people are interested in
That's
that.
great. Yeah.
Now, I want to give everybody an opportunity to either give a closing statement or, you know, tell us what you're doing in the future that you'd want to invite folks to, any kind of announcements that you want to make. That would be fine too, but why don't we start with Amy since she went last time.
Oh, okay. Well, you know, there are some policies at the state level that we are trying to get to give more protections for kids, like the Safe Playing Fields Act, and it's not going to move forward this year, but it will. Maybe we can create some momentum. But it basically, you know, requires people, public health professionals, parents, and kids, you know, who are on these fields and in these schools to speak up and keep track of the information, you know, be an informed consumer, you know, like don't just assume that because they say it's safe, it is. There is no safe pesticide of any kind. And so the best thing to do is not to use them and to do some of the things that I recommend, and have a little bit of tolerance for the pests. They're not, you don't have to be at zero. So that's my closing thoughts.
Okay,
Nancy,
thank
Brian?
you. Thank you, Amy.
Mhm.
Nancy, do you have any closing thought?
No, I think what Amy said is really important. And all I would say is that we are in the midst of another birth cohort study, and we're going to be looking eventually at pyrethroids as well as organophosphates to see health effects among a birth cohort and following our kids for 3 years. So we're continuously trying to understand health effects, and we're also looking at how differences in the microbiome or the bacteria or that you have in your gut, how that may impact you know, your ability to deal with these kinds of chemical exposures. So if anyone has questions or thoughts about this, you know, you can always get a hold of us at EOHSI. We also have a clinical center. And so if you are concerned about health effects, or you think that you have had an exposure and you are having some health effects, we do specialize in seeing patients, both adults and children, who have had exposures and concerns. So just keep that in mind. That's a resource.
Thank you, Nancy. Brian, do you have any?
Yes, so
Closing comments.
we will continue what my science are figuring out new ways, more effective ways to measure who's exposed to what and in what quantities. And we're working on a bunch of different projects right now, as well as I'm collaborating with one of my former mentees who's back in Thailand and her student. And I just saw his presentation where he's going to prepare, do an assessment of rice and corn farmers in Thailand. And so everybody's getting the message about the need to protect anybody who's in and around pesticides, whether by choice or by chance. And the only thing, just to kind of restate what Amy says, because it's been my catchphrase, my gentle reminder to everyone is it's really tough to kill the bad guys and leave the good guys unharmed. You just not enough difference in the DNA, gang. So just keep that in mind. That's
an excellent slogan. I think we're going to have to create a T-shirt with that tagline, Brian. An EOC T-shirt with that tagline on. But I just want to say thank you to all of our presenters and friends. Our presenters, friends, and colleagues. We love to have community-based organizations have a relationship with our researchers at CEED, and this conference is an example. This summit is an example of that, and everybody was fabulous. You're getting great. Robin Wilson just said thank you for a great set of presentations. Mike is screaming, keep promoting an anti-lawn aesthetic and psychology. That would go a long way to reducing contamination. So just one more thing, aside from thanking everyone that participated in creating this, on December 15th is our next session, and that's going to be facilitated by Father Miguel Hernandez. And that's our faith-based session. So join us December 15th for our next session. And we're going to be going on into the winter months. So we're going to keep on with this topic. And we appreciate you guys for attending the conference. I'll be shooting out a very quick 3-minute survey in the next day or so. And if you could fill that out, we would appreciate it. And then last but not least, the video will be available as soon as we can. Maria will put it on our website. So if you would like to watch this again or share this with a friend, you can. So thank you very much for this session. It was a very, very important session. And we'll see everybody on December 15th.
Thank you all.
Thank you.
Thank you.
Bye.
Thank you.
Have a good holiday, whatever it might be.